as we move forward. Huh? Didn't get what? You can review the video. I said it. So let's talk about building this wolf. Let's build a wolf. Let's pretend you're aliens and you're trying to build a wolf. You need some kind of carbon if you're going to build a wolf, because you got, where's the source for carbon in an animal? It's food. That's not true for plants. Plants don't, their carbon source for plants are what? What's the source of carbon for plants? The atmosphere. They use the carbon dioxide in the air to make is a carbon source for them. So animals use carbohydrates, proteins, lipids, and nucleic acids to get carbon. We get carbon from all those. Anytime you eat, this is where you're getting your carbon. Phosphorus is used in nucleic acids and some lipids, and we get it from our food as well. Oxygen, we get it from where? Atmosphere, correct. A plant gets carbon from the atmosphere, and it makes carbohydrates, proteins, lipids, nucleic acids. See, what do? We eat them, and then we rearrange the atoms to make what we need. But they actually make these. Plants are the source of all these molecules. In plants, carbon is stored as starch. This is going to be important. You need to know this word starch. Starch is found in plants, not in animals. You know starch very well, don't you? What things that you eat have starch in them? Potatoes, number one. All plants, right, have starch in them. But potatoes are their big function is to store starch. It's a storage form of carbon, of sugar, glucose. Phosphorus, where do plants get the phosphorus that we eat, right? We eat the phosphorus, we need phosphorus, we make our DNA from phosphorus, we make a lot of our lipids, our cell membranes from phosphorus. What do we use, where do we get our phosphorus? From plants. Where do plants get the phosphorus? The soil. They get it from the rocks, broken down rocks. So the source of phosphorus for your DNA is rocks. Nitrogen. What is the air mostly made of? We learned this first thing this year. Nitrogen. You're right, there's a good percentage is oxygen. You should be taking these notes, not staring at the board. Nitrogen is the big component here of the atmosphere. It cannot be used. No, only a few organisms can actually capture the nitrogen that's in the air. N2, nitrogen gas, is not usable by us. We can't make N2 gas, two nitrogens bonded together. I think there's 3 bonds, don't quote me on that. Two nitrogens bonded together is not usable by humans. Are we clear? So we have to have these little things called bacteria to help plants capture the nitrogen. Nitrogen's in the soil, plants can use. Plants can't use nitrogen in the air. But nitrogen's in the soil, they can use. We store our carbon as glycogen. We store our carbon as glycogen, either fat or glycogen. Your fat is a storage form of carbon for energy. We store our energy. But glycogen is what you store in your liver. It's what is released when you wake up. It's the sugar in your blood when you're not eating. It comes from glycogen. So just like plants store sugar in starch, humans and animals store sugar as glycogen. Two different forms of the same molecule put together in two different ways. Nitrogen, of course, animals eat. Are we all good with that? Here are some inorganic ions. Inorganic meaning what? Not from life, but specifically not involving carbon. Remember, in biology, organic means carbon-based. Ions that are not carbon-based. There are ions that are carbon-based. But these ions are not carbon-based. You will find all of these, almost all of these, you will find in your vitamin pill. Calcium, magnesium, iron, sodium, potassium, chloride. Sodium chloride you eat all the time. You call it table salt. Potassium, you'll find a lot of those in root vegetables. Bananas, a lot of potassium in bananas. Nitrate, there's a lot of nitrate in hot dogs. Nitrates, this is the form of nitrogen that plants love. This is what's in fertilizer. This plants can eat. How do you go from this, N2, to this, NO3, negative? A bacteria. Bacteria have to make that. Or fungi. We live closely with these things called bacteria. A lot of people want to kill them all. They pull out the bleach. They want nice, clean surfaces, right? You don't want any bacteria anywhere around you, right? You would die without bacteria. We would all die. We need them. All right. State the main source of carbon, phosphorus, nitrogen for animals. One word. Anybody? Food. Easy. State the main source of carbon for plants. State the main source of phosphorus and nitrogen for plants. Soil. Plants make their own food. List the 4 main macromolecule components of living organisms. Explain why carbon is so important for building the molecular components of an organism. Did I? Explain why carbon is so important in building molecular components of an organism. Why? Why is carbon so important? No one knows? Or no one's thinking? Let me pick some names at random and then give you points or take points away depending on whether you answer or not. Perhaps that will, I hate using names in videos, but perhaps that will help. Waiting for the computer program to log in, checking out. Let's see. Bancoli. Why is carbon so important?
Carbon's in water.
Carbon's not in water. Wrong answer. Look at water again. Learn it. Study it. Everyone should know that. No one should ever get that confused. Water has no carbon in it. Connors. Why is carbon so important, a building block for molecular components of organisms?
Something with bacteria.
I've said it numerous times in the last week. Yeah.
Oh.
Because we need it.
Right, but what?
Carbon is because it's a source for us.
Go ahead, you.
Carbon forms a key point of all living things.
That's right. That's it. That's all? That's it. Carbon. Yeah, how come she's the only one and I had to call out names and start calling people out in order to get someone to answer that? If it's so simple. Yeah, whatever. Carbon is the key component to all the main macro molecule. That's one of those things that you were supposed to memorize. You were supposed to know that. You're supposed to know what is a lipid mostly made of. You need to know that for tomorrow's quiz. What is a lipid made mostly of? What are the components of lipids? What elements make up lipids the most? Carbon and hydrogen. Mostly carbon and hydrogen. Some phosphorus, some oxygen, but mostly carbon and hydrogen. What are the key components of sugars? Carbohydrates. It sounds like some people have some studying to do. Carbon, hydrogen, and oxygen. Should have been highlighted. I posted the video, I highlighted in the videos. I said it was going to be on the next quiz. Carbon, hydrogen, and oxygen. What is the key component to proteins? The key elements in proteins. Key elements in proteins. Carbon, hydrogen, oxygen, and nitrogen. There's some sulfur, but no phosphorus. I said you need to know this. Is this coming on the test? I told you this a week and a half ago. Nitrogen, a big component of proteins, the thing that makes proteins very special, a big source of nitrogen. What's the key components for DNA? Schnapps, all of them. Okay. Specifically carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. But in all of these, what element is in all of these? In abundance. Carbon. The key component for all macromolecules. I don't think that's something that should have been hard to do, what we just did. But I'm moving. I put lipids here twice, and I erased one. I should have also added what? What's one's missing? Proteins, lipids, nucleic acids, and what?
Carbohydrates.
Carbohydrates.
You ain't gonna fit all that.
Boom.
Ew, I don't even know what that means. What did I say? All I see is carbs.
That's all you need to know. It's carbs.
Right, just put on the other side.
No, you said I couldn't do it, so now I'm going to do
Oh
it.
my God. I gotta be able to read it. Right, boom.
You gotta move it over.
Oh my gosh. Oh yeah, that's what I thought.
You should make it look sloppy so she can read it.
You know, even a broken clock is right twice a day. Just remember that.
Huh? A broken clock is right twice a day? I don't like thinking.
All right.
Right, I'm sure.